All right. Okay, so I guess before I do anything, I should probably ask. Well, I don't even really want to talk about SQL exactly just yet. So this should look familiar. So this is from a previous exercise. We have a CSV file, and I removed the password field. Just keep it a little bit simpler and not encourage bad security habits. But so we have this CSV file, which is supposed to represent a table. So if this were a spreadsheet, we'd have a nice, you'd see all the columns and it would be very linear and satisfying. CSV file looks a little lumpy, but we can pretty easily impose that schema on it. And so how would you describe a row for this given table? What is a row here?
I mean, I think I know the real word, a record.
A record, yes, yeah. So it's a record, a row, a tuple. That's where that originally comes from. So there's a lot of different database terms. Sometimes 3 or 4 words for the same thing. But I'm kind of asking more like not at a technical level, but like what real life thing is this supposed to represent?
A student
Yeah.
or a person.
Sorry, go ahead.
Oh, I said a student, but I don't know if somebody else started to say something too.
But yes, yeah. So a student is correct. So I would say that each one of these rows represents a student. Or so sometimes you'll hear something like what is the grain of a table, something like that. So like what is the granularity of a record or a row or an instance maybe of this particular table. So yeah, I would say that each one of these records is a student. Okay, so we've seen this, and we can also have this. We can also represent this a slightly different way in Python, for example. So here, so how might we represent this in Python?
Key value pairs.
Yeah, we could definitely do that. So we could do something like so there's a couple ways we could think about it. So we could represent the entire thing. So we could have like students, and we can have maybe like how would we do this? So what would the key values be here?
ID.
Okay, we could do ID, but then if we want to have lots of students.
I was thinking more of like how when you open it and pull it from a CSV, it creates like a list of dictionaries. So it's
Okay.
just a list of key value pairs. So you'll have all of those individual dictionaries.
Okay, cool. So let's say we have a list of dictionaries, and we can have a dictionary, and we can have name Lisa, and then maybe age. So we could create a bunch of these dictionaries, right? You do something like that, just create a whole bunch of them. So a list of dictionaries. So you could definitely do that. Is there another way? So maybe we could start talking about some pluses and minuses of representing this data in different ways. So let's talk about the positives of of using a CSV file. So one is that it's just a plain text file. So it's pretty easy to look at, and I can come in here and add a new row if I want, or I can make some change. It's very easy to see and interact with. The downside is that the structure is really it's really kind of imposed by the programmer or whoever is looking at it, right? There really isn't any actual structure here. Like, this is just a text file, so I could do something like this and then keep doing stuff, even adding different stuff. And this is like, it's not going to complain, it's just a text file, right? So it's not, it's very flexible, and it's very transparent, but there's no real, there isn't really a structure that's imposed on the data, which might be, you might want to have structure imposed on data, especially if your data is very important to your billion-dollar business or whatever. So here, one way we could represent this in code is to create a bunch of dictionaries, and it's actually similar in that there is no real structure here, right? There's nothing imposed. I can pass in whatever dictionary I want here, and my Python itself is not going to complain, right? So it'd be easy to kind of corrupt this data. The quality control is not real high. Is there another way that we could represent students with a little bit more quality control?
As a class?
Yeah, I think a class would be, so we know that each one of these rows represents a student, right? So a student. And we know kind of the shape of a student, the general shape of a student. We know that it's going to have these four fields or properties. So we can represent that. So class student. And we can pass in name, age, role, school ID. And we'll just kind of do this boilerplate. Okay. So now I have a student, and I could similarly, maybe I could do students. I could still have a list of students, but this time I could do students, and then I could do Lisa 25 students, and whatever the ID is. So I could create a bunch of these, right? So this works. This gives me a little bit more quality control, but I could still, so Python is dynamically typed, so it's very permissive here. So even though, like, I know that a name is supposed to be a string, and I know that age is supposed to be an integer, that's not really enforced anywhere, right? So there isn't really a built-in way to enforce type conformity. So I could still do something like I could pass this in, and this will still run. So Python is perfectly happy to accept this, even though this is not semantically, it's not what I want. But it's permitted. But there is still some control here, right? So I can't just pass in. I can't try to create a student just like that. I'm going to get an error. So this gives me more control. There's fewer ways for me to mess this up, but it's still possible to kind of mess this up. Okay, so in general, we can have a CSV file, and then we can have a Python class. We could also do some type checking here. We could do something like if name, actually, do something like, I think that's what you do. I'm not sure. I have to check this, but I could raise exception. Whatever. So I could like specifically check types here, and then throw an error if an invalid type. So I could definitely add that stuff there, but I have to, it's not really built into Python. It's not really built into the language. So it is possible to do something like that. So another way well, yeah. So another way that we could represent the same kind of notion of, we have, a general template called student, and we want to create a bunch of instances, is to use SQL. So I'm going to write a SQL script here, and I'm basically going to create this table, but I'm going to do it in SQL. So create table, and I'll call it student. And then just like, one second. So just like here, I can kind of tell it what the fields should be. So I know I'm going to have a name. And then I can also, unlike Python, I can be more specific about the type here. So varchar, I can say, so varchar is basically like a string in SQL. So varchar just means variable characters. So, and you can pass it a number, which is the upper limit. So what you're saying is name is going to be a string that's 100 or fewer characters. So that's a lot more specific than this, right? You could definitely implement a check like that in Python, but it's a lot of work. So this is just built into SQL. So that's a nice feature. And then I can do age, and age can be an integer. And there's a whole bunch of there's maybe a dozen or so different data types in SQL. And we'll do roll. That's also going to be a string, so varchar. And we'll just say that can be 10, and then school ID, which is also string. Actually, let's say this is an integer. Yeah. So I have these keywords capitalized. SQL is not actually case sensitive, but SQL's been around for a very long time, before all these fancy editors and highlighters and stuff. So by convention, you use all caps for this, but you don't have to. I'll do this for the first day, and then I'm going to get lazy and just do lowercase. Okay, so I can create this table, student, and I can kind of define its structure, and I can impose some limits here. So I'm going to save this, and then question is, so I have this script that's going to create, my students table or class. We'll call it a table, or a relation is often a term that you'll hear. That's a more technical term, but yeah, table, relation. How do I actually create that? Well, the first thing I'm gonna have to do, I'm gonna have to put this table inside of a database somewhere. So what I will do is I'm going to create a database, and you can check if this works. If this doesn't work, we set this up, on the first day. But if it doesn't work, that's fine. Don't worry. We'll take care of it. But I can do PSQL. So I'm going to use the Postgres command line tool here, PSQL, and then I can just pass it a string, and it will try to log me into whatever database that is. So if I do school, so I want to have a database called school. Well, I get an error. Database school does not exist. So I can't just log in. I have to create the database first. And you do that with create DB and then the name of the database you want. So create DB school. And I got no response, which means that it worked. So now I can do PSQL school. And now I'm, inside my database. So I have basically like a shell interface. So I'm going to use this for now, even though it's not the prettiest thing in the world. I'm just going to use this one because it's the kind of lowest level thing you can have, so it's good to be familiar with. But there are other tools. There's pgadmin for Postgres. There's a bunch of GUI interfaces for databases that you might want to use. Okay, so I'm here. This is kind of a little weird. There's a few arcane commands that you might become familiar with. So there's /d, and this means describe. So I'm saying I'm inside of the school database, which I just created. So please describe this for me. It says didn't find any relations. So a relation is a synonym for a table. So I created this database, but it's empty. So I created a database and said, hey, database, tell me about yourself. And it says, I don't have any tables. So what we're going to do is we're going to execute this statement, and we're going to create a table in this database. So you can execute these commands on, right here, but I'm going to use the script just because it's easier for everyone to see. So I'm going to exit out of this, which is /q. So now I'm back in my normal shell here, and I'm going to execute this this file as a script. So PSQL, and then I'm going to give it the database that I want to execute the script in, which is school. And I'll pass it -f flag, which means file, and then the file. So I'm saying Postgres SQL, I want you to execute this file, creation.sql, on the database school. So it should do that. And I get some feedback, create table. How do I know that it's worked? Well, I'm going to go into the database again. So PSQL school. And then I can describe /d. And now I have this table. So you don't have to worry about all this stuff, but we have a student table now. So I can further describe that table that I've created. So /d student. And then I get this output. Is this, can people read this? Is this large enough, the font? Or if you can't read it, let me know, please. So I can see that I have a description, which again, maybe is not the prettiest, but here I have a bunch of columns. So name, age, role, and school ID, which I created right here, and the type. So here in Python, specifying the type wasn't really an option. In other languages it is, in Python it's not. But in SQL, you can specify the type, and it's character varying, varchar 100. And this is age integer, and so on. We have some other fields which we don't need to worry about right now. But that's the basic idea. So I'm going to quit this. So now we've created this actual table, right? Now we look over here at our Python example, we have this general definition of the student, which is kind of like this. So we've created this table, but there's nothing in it. So we need to create instances, right? We need to add rows or create instances. And we can do that in SQL as well. So I'm gonna, if I should do this. Yeah, I'm gonna do this in another file. So I'm gonna do. Okay, so I have this table student, and what I want to do is create a bunch of instances of the student. And SQL has a way to do that. So the command is insert into, and then you pass it the table name. And then you need to give it the columns that you want to pass in. So student is the table, and then I'm going to pass in all the columns that I want. So name, age, role, and school ID. And then I have to pass in the values. So I've given the columns, and now I'm going to say, so for each one of these columns, I want you to give me an instance which has these values. So, whoops, values, and then you do the same thing. And we're going to pass the specific thing. So just like we're creating an instance here, actually I can just copy this. I'll put this on another line. So white space, SQL basically doesn't care about white space. And we can end the statement with a semicolon. So in JavaScript, semicolons are 99% of the time optional, but in SQL, you need to have a semicolon at the end of a statement. So now I've created a student, a particular, so I can execute the script. So I have I've run this, I've created my table, created my database, created my table. Now I want to populate it. So I can run this. So PSQL, and then the table name, which is going to be school. And I'm going to pass it a file that I want to run as a script. And that file is add data.sql. So if I run this, I get an error. So the error says PSQL add data, blah, 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 SQL2 error column Lisa does not exist. Very strange error. And then I get, so it's happening on line 2. That's helpful. And then I get this little caret, which is pointing me to where or near where this error is occurring. So you'll find as you're doing SQL that the error messages are pretty unhelpful most of the time. So does anyone happen to know what the actual problem is?
Should it be like a single quote?
Yeah, exactly. So in Python, for example, single quote and double quote basically are the same. That's not the case in SQL. So if you use double quotes, it's expecting a column name. Like here, we didn't. But if we use double quotes, so if we use double quotes, SQL expects it to be a column name. Here we don't want a column name, it's just a value. So we have to use single quotes. So that error message, it's not obvious what the actual problem is, but that's what it is. Okay, so I get this feedback, insert, I've inserted a row. So I'm gonna go ahead back into my database and see if I can see what's there. So I'm gonna go SQL school, and I'm gonna describe student. And I can see that the basic schema is the same. But I want to see, I want to see this actual instance. So the way to get at an actual instance is we're going to have to write a query. So everything we've done before has basically, so we've created stuff using SQL. We've added data using SQL. And now to actually see that data, we're going to have to write a query. So the query part is kind of, what you'll spend most of your time doing or worrying about. But so let's do queries. I could also write this directly, but I'm going to write it here just so we have a record of it. It's easier to see. So how can I see what's in this database? Well, you can do write a select statement, and I'll write that, and then I'll write it and then describe it. Select star from student. So this is basically the simplest possible select statement that you could write. And so the way this works is I basically a select statement is I'm writing a query. I want to ask the database a question, and I want to get an answer. I want some data back. So you select, and then this star, whatever goes in this slot is the columns. So star means every column, but I could also be specific and say name. So select and then column or columns, and you can pass in multiple as well. You can do name, comma, role, from, and then the table name. So select columns from table name. And so I'm going to go back to select star. And I'll exit /Q, and then I will run this script. So PSQL school, the name of the database. I'm going to run the script as a file, and then queries.sql. And I can see the result here, which should match the record that I just created. Lisa 25, student 1, 2, 3, 4. So I write a query and I get back a result. Now this result is just basically printed to the, it's just printed to the terminal. So there's not, you can't really like do anything with this data anymore at this point. We'll see when we start getting into Django soon, that there are Python adapters. So people write adapters that will turn SQL into Python and vice versa. So you could write a query. You'll use Python in later on in the course. You'll use Python to actually write these queries. So use Python and that Python will get interpreted to SQL. That query will run, get a result, and then the adapter will transform that SQL into Python objects that you could then use in your application. So that's the ultimate goal. But here we're just kind of getting a printed response. Okay, so I can select star from student. All right, I'm going to go ahead and add a couple more. Let's do just so we have something to look at here. And I'll do 4. Lisa. Okay, and then 25. 45, 55. Okay. So I have a bunch of data that I'm adding. So I'm going to run this again. Because I want to add some more data into my database. I'm going to go ahead and run this again. All right, I should have the query already up. So run that. And I get an error. So it says, let's do syntax error at or near values, line 3 values. So let's see. I'm not actually sure why this is an error. One second.
Does it need semicolons?
It shouldn't need, I think I just don't need the values keyword every time. Okay. Do that. It should work. Yes, okay. Cool. So I ran this again. Now if I go and I'll query, so we'll query this data now. So I'm going to run queries. So look, you'll notice that I originally ran this and then I ran this again. So I now have duplicate data in my database, which may not be what you want. And on Saturday and later, we'll talk about ways you can avoid doing that. I'm gonna skip that for now, but that's just something to be aware of. So what I'm gonna do, just for the sake of the exercise, you don't need to worry about it right now, but I'm just gonna add another statement here, which is I can like drop and recreate the database. It makes developing easier. So drop drop table if exists. So I'll just run this and basically it's gonna remove it and then recreate it when I rerun it. So I'm gonna do, so I dropped it and recreated it, and now I'm gonna add the data, but it's only gonna run that once, and then I can run the query, which is gonna give me the data without that duplicate record. So I can create it, add new stuff, and then query it. Now the queries can also get, you can do a lot more than just select star. So first off, instead of select star, let's do select, let's do name and age. And I'll run this query. And I only get name and age. You can also basically filter or limit records. So here we're just requesting everything. That's often not what you want. So I can do, I'll do select star from student, and then the way you limit is a where clause. So where is like filter, where age, and then you can pass in a condition here, which can be just about anything. So I'll just do age is less than 40. And we only get these 2 students. So I'm not going to go into all that stuff, but just to expose that to you. you can you can specify particular values, you can do ranges. Yeah, there's all kinds of things you can do. But that's the basic idea. Okay. So I think with that, why don't we take a break and then I'll come back and we're gonna see what happens when we need to add another some more data, basically. Okay. So we've got our table, our students table as a CSV file, and we can kind of represent that same basic idea as a class in Python. We can create instances here. We can create rows here. And then we can query that data. We could also, query the data here in Python. We could loop over students and then check, we could do something like for student and students, if students dot age is less than 40, something like that. Yeah, so I'm gonna get rid of that one. And we don't have a string representation, but anyway, this is working, right? Okay, so let's say that we now have another table or some more data. So we have this other teacher's CSV with name and subject. Well, we can do the same thing with Python, and we'll basically repeat everything. So class teacher def init. Okay, and this works, and we can create instances of teachers the same way. So teachers okay, and this works just fine. So the question is, what if, so if, we can think about these tables in isolation, but in the real world and in applications, there's often, you want there to be a relationship between two different entities, right? So students and teachers don't just exist, as totally independent things in the world. Students have teachers and teachers have students. So we'd like to be able to kind of express that relationship in some way. And there's a few different ways we could do that. In code, we could, give each student pass a teacher instance, or we could do it in the reverse way. So I'll do it a slightly different way, just for the sake of making the parallel a little easier. Is I'm gonna say student, so self dot teacher name equals teacher name, and we'll do teacher name here. We'll pass in a teacher name, and then we'll do Mr. Bob and Mrs. Smith. So something like this. So now we have a way of kind of saying that there's a relationship between a student and a teacher. We can do something similar in SQL. So I'm going to create another table called teacher. And by the way, there's some debate as to whether these should be plural or singular. So it doesn't really matter. I'll use the singular. And we'll do name, and that will
Are you
be.
talking about the word table? Like,
Oh, no,
tables?
student. Whether
oh,
like table names should be plural, like students versus student, or teachers versus teacher. So it's kind of like, what does this represent? Does it represent a collection of students, or does it represent kind of the criteria for an individual student? It's one of those things that some people like to argue about, but it don't really matter very much. So subject, we'll do bar, and I'll say that's 20. Okay, and I need to put a semicolon at the end. Okay, so now I can I'll add this same drop statement just in case we need to rerun it. Okay, so now I'm gonna run creation. Okay. So I dropped the table, this first line ran, and then I get a little warning here because it tried to drop a table that doesn't exist. That doesn't throw an error, it just, I get a warning, and then I drop a table that doesn't exist, and then it creates these two new tables. So now I can go into the database, PSQL, and I can describe it, and I can see that I have two databases now. I have student and teacher. And then I can look at that, and you'll see that it's the same. So I won't go through that, but so now a database has two tables. And so there's two tables, but we have the same issue where these things, have a relationship between each other, but how do we express that? So there is a way that SQL does that. I'm not going to get into that today. I'm going to keep it simple. This is not, just so you know, there's a good way to do this in SQL, and this is not it. But I'm going to add another field here for students, just like I did here with the name of the teacher. So I'll do teacher name, and that will be varchar 100. So there's now a way to get from a student to a teacher, right? I can connect these two entities. So I'm going to run this creation statement again. And now if I go to populate this stuff, I'm going to have to modify this a little bit, but I'm going to write another insert statement. So insert into, and this time I'm going to add a couple teachers, teacher. And I have to pass in the column names, which are name and subject. And then white space doesn't matter. The specific values that I want to pass in, single quotes, and then Mr. Bob, I guess. And math, and then the other. Okay, so, but I modified my schema, so I'm gonna have to modify this. So I'll try running this, and you'll see that I get well. So there's a question like, will I get an error here? So I will run the add data, and it actually does work. I don't get an error. Without going into too much detail, SQL also has a null value, which is the absence of a value, and it will default. So I passed in name, age, role, school ID. I didn't tell it what the teacher name should be, so it defaulted to giving a null value to teacher. So if I now run this select statement, I'll just make this select everything. I can see that teacher name, this is represented as just like an empty string, but it's blank here. So this blank is actually a SQL value called null. Now you can, as I mentioned, you can get pretty specific with constraints, database constraints. So here we're saying that teacher, it has to be a string and it can't be more than 100 characters. You can also make it not null. So I'll just do that here. So not null. So now I'm going to recreate the database. And if I try inserting this data, now it's going to blow up. So there's an additional constraint that I added. So this is one of the benefits of SQL over just using a plain text file or dynamically typed language like Python, where you can be pretty specific. So it's harder to corrupt your data. It's harder to add records that are different than what you expect. So I'll go ahead and add this guy. Okay, then I'll run this again. And insert has more expressions. Okay, so what I did here is that I added the values here, but I didn't add the corresponding column. So I need to add teacher name. And now this works. So if I run the query, I can see that this is populated. So I don't have null values here. Okay, so now I have this, teacher table and I have this student table, and I could query both of them. So I can do the same thing, select star from teacher. And I'll run these two queries. And again, I have this issue where I have duplicate data. So I've run this a whole bunch of times, and even though this one failed, this one succeeded. So I'm going to drop and recreate the database again. I'll add the
If
data.
you drop a table, is it gone forever?
Yeah. So this is only, I'm dropping this table very casually because this is just a demo, but and
I could definitely get into some trouble with that.
yes, yeah, definitely. Okay, so I've populated it, and now I'll run the queries. So I have these two tables. I have my student table and my teacher table. Now what I'd like to do, let's say I want to ask some questions here. So this is like a simple where statement. Now I want to find all of the students. Maybe I'll copy this over. should work. Does anyone see what I'm doing wrong here? Okay. So this should work. So I have a bunch of students and a bunch of teachers. And the question I now want to ask is, I want to get the subject that, I guess I want to get all the I want to get a result that shows me the student's name and the subject that they study. So I want to do get student name and subject. So how could I write a query? How could I answer this question in Python? Also, I would do a for loop, I think. So for student in students. And then I'd also, for each student, I'm gonna have to check all of the teachers, right? So then another for loop. So for teacher in teachers, I want to do a check. So actually I don't want to do a check. I just want to get that. So what I'm gonna have to do is I have to make sure that for every student that I'm only looking at whoever their teacher is. So for example, Lisa's teacher is Mr. Bob. So I only care about Mr. Bob's subject. Mrs. Smith is not her teacher, so I don't want that. So I have to check that. So if student dot teacher name is the same thing as the teacher dot name, then what I'm going to do is I'll just print the stuff out. So print, I will print the student dot name and the teacher dot subject. So if I run this, why did this stop? Oh, because I changed the data here. Okay, so the result I get, I basically have to go through each student and then kind of join this. So what I want is to create kind of one big record. So I have two tables with their own records. What I want is to create one big record that kind of combines the students and the teachers. So if I have students over here and teachers over here, what I want to do is something like Mrs. Smith. Oh, I don't have that data, the made up data here. But what I want to do is that I want to take this and then kind of like add it onto here, right? So I get everything from both tables. And that's, in Python, this is, there are maybe cleaner ways to do it, but it's Python isn't really built for doing something like that, whereas SQL is. So what you can do is you can query specific tables, but you can also take two different tables and combine them together, and that's called a join. So what you can do is select. I'll still select all the columns, but so from student, and what I want to do is I want to join. Let me look at the tables here. So I want to take a student and I want to join it to teacher. So I want to answer this question of, I want to get all of the subjects that a given student has. So I'm gonna have to join, the student doesn't have all the information that it needs, it just has the student name, it doesn't have the teacher's subject. So I'm gonna have to join it to get the information from teacher. And then how am I going to join it? That's the question. So my connection is this teacher name. So student teacher name should be the same as teacher name, right? If Lisa's teacher is Mr. Bob, then this teacher name should be Mr. Bob. And then if that's the case, then I can grab the subject. So the way you do this in SQL is I'll select everything from student and then join the keyword. And I tell it what other tables to join to. So I want to join student to teacher. And then I can do that. So now I can connect these two tables, but I haven't told SQL how to line things up. So it just knows that I want to somehow combine the student table with the teacher table, but you have to tell it how to line things up. And you do that with the on keyword. So on. And we know that student teacher name should be the same as teacher name. So you can just specify that here. So student dot teacher name is the same as teacher dot name. And notice that there's no double equals here. So I can execute this. And what I get, so I have each of these individual tables printed. And then what I get here from this join statement is both of these tables combined and lined up the way that I've specified. So you can see that teacher name and name are always the same, Mr. Bob and Miss Sally. So I've basically taken two separate tables, which have some way of connecting to each other, and I've connected them together. So this table doesn't, I haven't changed my database at all. I haven't created a new table that has the combined data. This is just a presentation. We can do this. So now, initially I selected all the columns, but I'm going to be more picky here and I just want name and subject. But notice here that we have two names. So I'll just do this. So name and subject. I'll run this query and I get an error. It says error, column reference name is ambiguous. So there are two tables that have name columns and SQL doesn't know which one I meant. So I can be specific. I can say student dot name and then subject. Only one table has subject, so that's fine. And here I get the results. So Sam, math, and so on. So that's the basic idea. Again, this join, SQL has a way of doing this that's better. So there's some additional features, but this is the basic idea. So you can create a table and you just describe the columns, which is analogous to a class and instance variables or properties. And then you can be more specific. You can tell it what data type. There's also a lot more advanced things you can do, and then you can not only create a bunch of individual tables, but you can specify, you can think about how they could be combined, and then when you write queries, you can actually combine that data. Okay, I think that's that's it for your initial exposure to SQL. Are there any questions?